The James Webb Telescope shows us the miracles of the universe in uncommon detail. As the most remarkable space telescope ever built, Webb is 100 times more precise than its ancestor, Hubble, and might effectively see into the most profound mysteries of those designs that seem to be totally undetectable to the instruments of the past. And while the $10 billion gadget has already uncovered one or two astronomical secrets, it also reveals the incredible beauty of the universe. From smiling galaxies to a grandiose question mark, and a multitude of stars that will leave you completely stunned. Smoking is unhealthy, but space pilgrims can't resist the urge to grab a cigar now and then. Luckily, however, this particular cigar star doesn't produce any putrid smoke, but rather intense bursts of star formation, which have now been thoroughly analyzed by the James Webb Telescope. Otherwise known as the Cigar Galaxy because of its unique shape, M82 is famous for its intriguing starbursts. Essentially, this refers to periods of rapid and efficient star formation. But tragically, most starburst galaxies are so distant from us that studying them in detail is very challenging. However, at a distance of 12 million light-years, M82 is a welcome exception. And although the Spiral Galaxy in the Ursa Major constellation appears relatively small, it is a prolific star producer. In fact, multiple times more new stars are born here every year than in our own Milky Way. Past observations were often hindered by the thick veil of dust and gas that naturally occurs here. Webb's infrared view, however, is now able to break through these blinders and, with the help of its near-infrared camera, even capture images of the true starburst center. While the dark brown dust veins penetrate the glowing white center of M82, even in this infrared picture, Webb gives us the design in an extraordinary level of detail. For example, we can see tiny red spots in the middle, where young stars make subatomic hydrogen glow. The green regions, on the other hand, represent the opposite end of the cosmic spectrum. Most of these concentrated iron-rich regions are simply supernova remnants, the first brown dwarfs outside the Milky Way. Is it a star? Is it a gas planet? No, it's a brown dwarf. In simple terms, these objects can be described as a kind of halfway stage between stars and planets. Brown dwarfs weigh between 13 and 75 times the mass of Jupiter. On one hand, they are too low mass to ignite hydrogen fusion inside them, but on the other hand, they are heavy enough for deuterium fusion to begin. Remarkably, these extraordinary celestial bodies can sometimes float freely through space without being gravitationally bound to a host star, like a planet. At the same time, brown dwarfs also share some characteristics with exoplanets, such as storm patterns or atmospheric features. While Hubble had already shown us that the emission cloud in GC6 O2 is home to a series of young low-mass stars, Webb's sharp look has now allowed us to study the first brown dwarfs outside our galaxy in greater detail. The small Magellanic Cloud, located about 196,000 light-years away from Earth, shows an open star cluster in a brilliant cloud of gas and dust in and around the gas cloud. However, various distant galaxies also grab our attention, as do several stars that are much closer to us and give the region a shimmering glow. Speaking of shimmering wonders, compared to the picture that Webb captured of Westerlund 1, the designs of NGC6 O2 almost look like weak fireflies situated in the constellation Carina, discovered in 1961 by the Swedish astronomer Bengt Westerlund. It is nothing less than the largest open star cluster known in the local group. A brief explanation: scientists refer to a group of galaxies, including our Milky Way, as the local group. The overflowing star abundance of Westerlund 1 means that 50,000 to 100,000 solar masses are concentrated in a region whose diameter is less than 6 light-years. A huge stellar population, but one that is also related to explosive results. Scientists estimate that more than 1,500 supernovae will occur here in less than 40 million years. At the same time, Westerlund 1 serves as a stellar laboratory for researchers to study extreme cosmic physics. Here, they can understand how the largest stars in our galaxy live and die, and how cosmic winds, supernovae, and other explosive material impact star formation in the surrounding regions. The dance of the galaxies. It nearly looks as though the two galaxies of ARP 107 couldn't be more happy about their destiny. Up close, we are dealing with two interacting galaxies in the Leo Minor constellation, a good 440 million light-years from Earth. While the larger spiral and smaller elliptical galaxies are about to merge, their cosmic dance creates an intriguing spectacle. The orange and red star-forming regions made of gas and dust together form a kind of smiley face. But the ring structures are not the only things Webb has uncovered here. Thanks to the mid-infrared instrument MIRI, we now also know that a nearly straight white bridge of stars is hidden here, which was detached from both galaxies. The bottom line, however, is that in a few 100 million years, these two cosmic partners will have merged to form a much larger, irregularly shaped galaxy. At the edge of the Milky Way, Earth is about 26,000 light-years from the center of our home galaxy. However, the so-called DLE clouds 1 and 2 are separated from the center of the Milky Way by a distance of 58,000 light-years. They are situated in a region that scientists refer to as the super-outer galaxy. A group of scientists use Webb's NIRCam to study specific areas of the two molecular clouds, revealing entirely new parts of these remote regions, which hide star clusters along with cosmic nurseries. Although the two clouds are part of our cosmic home, Webb is revealing more about them than we've ever known before. They are moderately poor in components, heavier than hydrogen and helium. As a consequence of this structure, they are more suggestive of Bantam worlds or the youthful Smooth Way. And, while Webb confirmed the previously associated presence with a subcluster in one piece of the picture, we also see weak planes reaching out in various directions from the brilliant structure. Music. The enormous question mark. Many cosmic designs are joined by a giant question mark, and another in a literal sense, as we can see in the following picture. The corresponding exclamation mark also appears to have a permanent place in the universe. In fact, the ESA emphasized that the picture is by no means a fake or a lie, but a couple of effectively forming young stars, logically assigned Herbig-Haro 4647s. Although the description has the potential to become an image, astronomers, unlike the Webb, are not making a big deal of it. It is not an impossible mark of development. Their primary focus is on observing the star development, a brief look into the planetary nursery. What is perhaps just a reflection cloud in the star grouping of Perseus, by definition, is also another surprising example of the natural processes that occur in the depths of space. Situated around 1,000 light-years from Earth, the design NGC 1333 is a huge star-forming region that is home to countless heavenly children younger than 1 million years. The mass of this region is estimated at around 450 solar masses. But that's not all, because while Webb's sharp infrared view additionally enters the dusty cover, in this case, we also see gas and dust plates in the picture from which new planetary systems may arise. The secret complexities of more chaotic 106 in a cosmic setting. More chaotic 106 is just a stone's throw from us. Nevertheless, the inestimable house cat would still need to cover a distance of 23 million light-years. As one of the closest and most brilliant barred spiral galaxies in our area, this galaxy also has a central, very massive black hole. But interestingly, this one seems to be especially active compared to the massive beast at the core of the Smooth Way. It devours significantly more material. And while the odd monster actively gobbles up dust and gas, more chaotic 106 also has another remarkable feature. It has two additional irregular arms that are only visible in the radio and X-ray range, not in the visible range. This is because these arms are not composed of stars at all but of hot gas. Astronomers suspect that their existence is due to some sort of feedback effect from the black hole. Essentially, they are likely formed by outgoing material created by the fierce flow of gas around the gravitational beast. Thus, it gets a cycle rolling that can be compared to a wave hitting a rock near the shore. the vast gem ring, where the gravitational lensing effect meets a distant quasar. The end result is an image suggestive of a ring set with gems. In simple terms, gravitational lensing causes the light beams of distant sources to be affected by objects that seem to lie in front of them. In this context, the designs behind them can be optically extended, bent, or, as in this case, duplicated. In detail, we see here with RxJ 131D231, a functioning cosmic core 6 billion light-years away, which is affected by the strong gravitational field of an intervening galaxy before it. The cosmic gravitational focal point presents itself as a small blue speck in the middle of the ring, while the orange, sparkling pearls show very much the same quasar in many versions. For researchers, however, the gravitational lensing effect is much more than an optical trick. After all, it occasionally makes objects visible that would otherwise be far too distant or too weak to be studied in detail without this natural phenomenon. And if you now look beneath our video, you will quickly find the like and subscribe button. We would love for you to join our community so you can stay up to date. From here onward, we'll see you soon